All right, so today we're looking at 5.2, evaluating trigonometric ratios for special angles. Okay, so we're looking at two common triangles that we often come by. So we have the 45, 45, 90. Okay, so then we have our sides 1, 1, and root 2. Okay, so the way I remember, usually I get my students to remember these triangles, but when we have our test, I'll just put these ones on the board. Just because obviously Core and C would have them in front of them. Okay, so usually I get people to memorize these, but I won't for this time. Okay, you'll be using these a lot next year in grade 12. Okay, we're just going to kind of touch on it in this chapter, but next year you're going to use this quite a lot. Okay, so what happens is we have an isosceles triangles here with 45, 45. So we do the ratios of the sides. Okay, so in the very basics form, the angles across, the sides across from the 45 are the same. Okay, so we put 1 and 1. This could be 10 and 10, it could be 20 and 20, 50 and 50, but in the very basics form, it's just 1 to 1. Okay, and if you were to do Pythagorean theorem, you add the two ones together and square root it, you'll get the square root of 2. Okay, obviously this would give you a decimal, but in the exact value is just the square root of 2. Okay, then we have the 30, 60, and 90. Okay, so the 1, so this is, I'm going to show you a little trick how I remember these triangles. So the way I remember them is 1, 1, 2. So 1 plus 1 is 2, and then 1 plus 2 is 3. And then what you do is you put the square root on the largest number, and that will give you your side lengths. So the first one is 1, 1, root 2. And the next one is 1, 2, root 3. Okay, but you have to make sure that the longest side goes to the hypotenuse. So if you were to square root 2, I believe it's like 1.4. So that would be your longest side. Okay, if you look at these three numbers here, the actual largest number is 2. So 2 is always going to go on the hypotenuse. Okay, because the square root of 3 I think is like 1.7. Okay, so the 2 always goes on the hypotenuse, and then the smallest side is 1, and that goes across from the 30. Okay, so again, root 2 is the longest side, so it goes on the hypotenuse, the other two are 1s. Here, our 2 is actually the largest value, so that goes in our hypotenuse. The 1 is the smallest, so it goes across from the 30, and then the root 3 is in the middle, so it goes across from the 60. Okay, you could go through these stuff here. Isosceles, 2 equal sides. 2 equal sides equals 2 equal angles, which is 45 degrees. And again, you guys can read those in the notes. Okay, now we're going to fill in this chart based on the triangles. I'm just going to write the triangles again. So 1, 1, root 2. And then we have 2, 1, root 3. Okay, so what the question is asking us to do is to find the exact solutions. When it says exact values, what that means is don't square root it. Okay, when you have a square root, don't actually put it into a decimal, keep it as a whole number. Okay, so on exact values, no decimals. Okay, no decimals. And also note, this is a rule, you can never have a radical in the denominator. Okay, so a radical being a root. Okay, so you can't have any radicals in the denominator. Okay, so if we come across one that has a radical in the denominator, we're going to do something to it so we can remove the radical. Okay, and you can always check your solution on the calculator. All right, so let's fill in this chart. Okay, sine of 30. Sine of 30. Okay, so we're going to find it on the triangle and see what sides it is. Okay, so right now I'm looking at the 30 degrees. So we'll do all the 30. So we're looking at this angle here. Okay, what is the sides we look at? when we're doing the sine? What sides do we look at when we're doing the sine? Spell it? The opposite and the hypotenuse, okay? So remember SOHCAHTOA. Okay, so opposite over hypotenuse. Okay, so if I'm going with the 30 here, what is my opposite? What is my opposite of the 30? Andrew?
The 1.
The 1, okay, and our hypotenuse is 2. So sine 30 is 1 over 2. Okay, so 1 is the opposite, hypotenuse is 2. Out of view. Thank you. And the glare is in the middle of cos. Okay, I'll do cos on this side. Okay, so 30 is the opposite, which is 1 over a hypotenuse of 2. So 1 over 2. Okay, now let's do cos 30. So cos of 30. What sides do we look at for cos 30? Sorry, for cos. We look at
Adjacent hypotenuse.
the adjacent and hypotenuse. Now we're looking at cos 30. We're looking at the adjacent and the hypotenuse. Okay, so remember this is hypotenuse, this is our opposite, so our adjacent is root 3. This is our adjacent side. So root 3 over a hypotenuse of 2. So root 3 over 2. A lot of good calculators will give you the answer. So if you plug in cos 30, depending on what mode you're in, it'll give you the answer of root 3 over 2. Most won't. Oh, sorry, let me write that over here. Just because it's in the glare. Okay, and the last one for 30 is 10. So 10 is our opposite over adjacent. Okay, so what's our opposite side of 30 and what's our adjacent again? 1 and root 3. Okay, so we're gonna put a different answer for this one. So 1 over 3 is the opposite over adjacent. So 30, 10 is opposite, which is 1, over adjacent, which is root 3. But there's a rule here that says no radicals in the denominator. And for 10, 30, we have a square root of 3 in the denominator. So we need to remove this radical. And I'm going to show you how to do it. Anyone want to guess what to do? I want to guess what to do to get rid of it. So I want to remove this radical. People at home, you could try to take a guess too. I want to get this radical out of the denominator. All right. Squared, good guess. Well, we don't square it. Very good guess though. Because that's the first thing that would have came to my mind too. Flip it, good guess, Owen. We're not going to flip it. It's going to look kind of flipped after. No, we're just dealing with these. We don't want to do reciprocal functions. Okay, so think about this. If I had to square root a number that's related to 3, that could go to a whole number, what would it be? I don't know if I'm asking that right. If you think about 3, what number relates to 3? Usually, when you're talking about square roots? 9, right? So if I square rooted 9, I could get 3. So how could I get this to become a 9? Well, what we do, it's a tough question. What we're gonna do is multiply it by itself. Okay, we're gonna multiply it by itself. So we're gonna multiply it by root 3. Whatever you do to the denominator, you must do to the numerator. So we're gonna multiply the numerator by root 3 as well. Okay, so when we do that, we get 1 times root 3, which is just root 3. And the denominator of root 3 times root 3, where does that become? You guys just did this on the test. When we multiply these, what do you get? Root 9, good. We get root 9. Okay, so 3 times 3 is 9, keep the square root. Okay, now this can be square rooted. So the square root of 9 is 3. So we get a final answer of the square root of 3 over 3. So to remove, you're going to have to know this for this chapter and for next year, to remove a radical multiplied by itself. Okay, so root 3 this times by root 3, so you multiply the numbers together, you get 9, and now you can square root 9 nicely till we get this answer. So our 10 is actually root 3 over 3, or 10/30. So it kind of looked like it was flipped, except for we still have a number in the denominator. Okay, now let's go work with the 45s. Okay, we're going to sine 45, cos 45, and then tan 45. Okay, so we're doing 45, so now we're looking at this special triangle here. So we're doing sine, so sine of 45, it doesn't matter which 45 you choose. Okay, but just to keep it consistent, I'm going to use the 45 here in the top left corner. Okay, so sine, we're doing opposite over hypotenuse. So what would be opposite over hypotenuse? It'd be what?
1 over root 2.
1 over root 2, good. So opposite would be 1, the hypotenuse root 2. So we get 1 over root 2. But again, what's the issue with this one? There's a root, a radical in the denominator. So we multiply it by itself. I'll just do it on the side here. So 1 root 2 times it by root 2 in the numerator and denominator. Which gives you root 2 over root 4. It becomes root 2 over 2. Okay, so opposite over hypotenuse, so 1 over root 2. But we have a radical in the denominator, so we multiply it by itself. So root 2 times root 2 is root 4. 1 times root 2 is just root 2. And now we just square root the 4, and we get the answer of 2. So for sine 45, it's root 2 over 2. Any questions so far? Any questions at home? Okay, so now we have cos. Cos is adjacent over hypotenuse, a over h. Okay, so we're still looking at the 45. What's our a over h? A over h. What would it be?
1 over root
1 over root 2 as well, right? So the adjacent is 1, okay, over hypotenuse, which is root 2. So again, this is 1 over root 2, which we just figured it out, is root 2 over 2. When you're doing the homework, guys, I would suggest maybe having this chart with you. I'm just gonna erase these. Oh, sorry. Put it over here. So root 2 over 2, the cos. And now tan is opposite over adjacent. Somebody else, what's my opposite over adjacent? 1 over 1, good. So our opposite is 1, our adjacent is 1. So we have 1 over 1, which is 1. Yeah. Christian, yeah, 1 over 1, which is 1. Okay, lastly, actually, I want you guys to try the 60. Try doing the 60. Sine 60, cos 60, and tan 60. Try it out. So now you're dealing with the 60, right? Yeah, I took out the cos, Deborah. So cos is on the side here. I just put a squiggle line through it. Oh, over here. Let's see if I can recenter this. I'll write in black for this. Cos 30 was root 3 over 2. Cos 45 was root 2 over 2. Does that help? Okay. You guys got it? Sine 60. Isabella, sine 60. Good. So 60 opposite over hypotenuse, so root 3 over 2. We don't have to do any adjustments to this one, so root 3 over 2. Okay, cos 60, right here.
1 over 2.
1 over 2, so cos 60 is adjacent over hypotenuse, so 1 over 2. Good, so cos 60, 1 over 2. And last 17, you got the 10. Sorry, root 3 over 1, so opposite over adjacent. Opposite over adjacent is root 3 over 1, or just root 3. Good. Okay, so 10, 60 is opposite over hypotenuse, so root 3 over 1, or just root 3. And you can always check your answers. So if you want to go backwards, just punch inverse sine of a half. So inverse sine, because you're doing the angle, going opposite. So if you did inverse sine of 1/2, you'll get 30. Okay, if you did inverse tan and pressed 1, you'll get 45. Okay, if you did tan inverse root 3 over 3, you'll get 30. Okay, so you can always check your answers to see if they match. So that was this, check your solutions. Or what you could do, if you do sine of 30, if you press sine of 30 in your calculator, you'll get 0.5, which is a half. So you can always check your answers. Okay, so I'm just going to go through one example here. If you guys flip to page 285. And when we go through it, try not to look at the answer. I just want to go through the question. So the question says, determine the exact value of this. So sine 45 times cos 45 plus sine 30 times sine 60. Trying to get it so it's not in glare. Okay, it works. So sine 45 times cos 45, and then sine 30 times sine 60. I just want to give you one example because you'll see them in the homework. Okay, so don't look at the answers they give you. Okay, so all we're doing is finding what the values are and plugging them in. So use your table. Or you can use the triangles. Okay, so sine 45, what was it in the chart? How is the hypotenuse less than the opposite for angle 60? Casey, it's not. So if you, so 60 degrees, 2 root 3 and 1. The number itself is larger, Casey. But if you were to actually square root 3, you get 1.7. So if you actually square rooted it, you get 1.7. That is actually smaller than 2. Does that make sense? Okay, good. Okay, so going from our chart, what was sine 45? Who said it? What was sine 45?
Root 2 over 2.
Root 2 over 2. So we plug in root 2 over 2, good. And it said the question, it says to do exact value, so no decimals. Okay, cos 45 was the same thing, right? So cos 45 is root 2 over 2, good. So we're just plugging in values from the table into the brackets. And again, you do a ton of these in grade 12. Sine 30.
1 over 2.
Sorry?
1 over 2.
1 over 2. And sine 60. Sine 60 would be root 3 over 2, right? Okay, so we're just substituting the values in. Okay, so now we're multiplying. So this goes back to last unit, multiplying radicals. Some of you guys struggled on like the one question where you had to expand it. So root 2 times root 2. So root 2 times root 2 is root 4. 2 times 2 is 4. So we have root 4 over 4 plus. So again, when multiplying fractions, we're multiplying the numerators together. So root 2 times root 2 is root 4, and 2 times 2 is 4. Okay, now we do the second brackets. Okay, multiplication following bed mass. 1 times root 3 is just root 3, and 2 times 2 is 4. I could remove the brackets, I don't need them. Okay, now what? Now what?
We can put it under one denominator.
Yep, so they both have the common denominator, good. So they already have the common denominator, so we're gonna make it one of them. So just the 4, and then we have the numerator, we add them, so root 4 plus root 3. Okay, we can't actually add them because they're not like terms. Okay, one's a root 4, one's a root 3. We can't add them together. But we could do one more thing.
Change the root 4 to 2.
Good, so square root of 4 is 2. So 2 plus root 3 over 4, and that is your final answer. Okay, there isn't anything else you could do. So again, we multiply numerators and denominators. Since they have a common denominator already, we could add the numerators. If it didn't, then you'd have to make a common denominator. Okay, so say this was a 4 and this was a 2, you have to multiply this one by 2 to make the common denominator. Okay, so then since they're the same, we add the numerators, and then lastly, we can actually simplify square root of 4 to the answer of 2. Okay, your homework, pretty simple, except for number 11 is difficult. Let's see how many you guys can get number 11. So 3, 4, 5, 6, and number 11. And then tomorrow, we could take up in the afternoon any questions that you have from 5.1 and 5.2. So again, page 286. 3 to 6 and 11.